Good morning now. Class, good morning. Now I will give you revision on lecture 8 and lecture 9, rotational motion. Basically, rotational motion, some students might think it's very easy since it's just like a linear motion, but then we consider a rotational part. All those are Newton's law and also conservation of energy, more or less just the same. But somehow, if you cannot conquer the previous few chapters, which means that this chapter you face a lot of difficulty. For rotational motion, it's still the same thing. We turn to the three variables. If for the linear, we have the displacement, we have the velocity, acceleration. Then in the rotational, the analogical part is just like this. Theta, omega, alpha, and of course we can consider that these are the so-called the vector or displacement, velocity, and acceleration. But their direction has a different meaning or different definition from the linear one. And what you can use is still the same. If I say that this is D, then the actual one, let's say I put it D, sometimes maybe you can put it as S is just r theta. D or S depends on the things that you define or variable that you define. On the other hand, V is R omega. And the last one, A is R alpha. That is the basic definition for the rotational part, rotational variables. Somehow, in chapter 2, we study all those vectors that is maybe to the right we consider positive, upward we consider positive. And here we have our own definition also, which is this one, we name it clockwise or CW. That one normally we put it negative. On the other hand, this one is counterclockwise or CCW, we define it as positive. Example, if I say there's a wheel, make a turn in the clockwise direction and it has to make a turn of 2 pi, then we may say that the displacement, angular displacement theta is negative 2 pi radian. Bear in mind, the most important thing in the rotational motion is the unit is radian. No degree. Whenever you use a degree, which means the whole chapter you can throw away, and which means that you get mostly get 0 because you are wrong from the beginning. Let me move forward. For the rotational part, we cover rotational kinematic. Sorry. In the linear kinematic, let's say x equal to ut plus half at squared. On the other hand, for the rotational, it's an analogy part, which is theta equal omega naught t plus half alpha t squared. This you can think of. Okay, compare each other, more or less just the same. But this is for the linear, this is for the rotational. On the other hand, let me give you another example. V squared equal to u squared plus 2ax for the linear one. Then for the rotational one, it's just omega final square equal to omega initial or omega naught square plus 2 alpha theta. Okay. By using all those kinematic equations, you can solve question that is related to these three variables. But also there are three groups or three clusters. First is when omega is fixed. Second is when alpha is fixed. And the third is when nothing is fixed, which means it's just a free motion, free rotational motion. So the third one is nothing. Okay? Nothing is fixed. When omega is fixed, all you need to do is just theta equal to omega t. That's all. One of a good example is the Earth. The Earth is rotating. Earth is rotating at the fixed omega, and the theta depends on this one. And if let's say for Earth, omega equal theta over t, And the theta, you know that for Earth to make a full circle, one revolution, the theta it move is 2 pi. And the time taken is 1 day. So 24 times 60 times 60. Okay, the answer. This is an example. On the other hand, if the movement involves acceleration, which is where the rotational acceleration or angular acceleration is fixed, then we can use all those kinematic. All those kinematic equations, which is something like this. Let's say rotational kinematic equations. Let's say omega square equal to omega naught square plus 2 alpha beta. We can use this one. And the third, which is it's not, omega is not fixed, alpha is also not fixed. For example, theta equal to 2 exponential to the power of minus t. When you see this one, definitely you know that nothing is fixed, then you can further use it. Omega is d theta over dt. Alpha is d omega over dt, which is also same as d2 theta over dt squared. It's exactly similar to the linear motion, but just that we change it to rotational. And in order to use it, let me give you one simple example. Let's say a view, car tire or car view, and the radius is, let's say is 16 cm, 0.16 meter. And this 16 cm for a car tire or vehicle tire or wheel, then it moves at the omega of minus 0.1 radian per second. Why is it minus? Because it moves in the direction, clockwise direction, which means that it moves forward. But in terms of magnitude, it's still the same, which is 0.1 radian per second. Please take care of this. And then it asks, what is the theta when they ask you to calculate the theta when t equal to 5 seconds. So it's quite simple. When you see this one, the omega is fixed, then theta is just omega t, which is negative 0.15 equal to negative 0.5 radian. Okay, the unit is radian. If we give you degree, please remember to change it to radian. On the other hand, if I say the car is accelerating now, the car is accelerating down, and the alpha given here is 0.1 radian per second square. Alpha is 0.1 radian per second square. And he asks what is the displacement it travels when t equal to 10 seconds. What is the displacement here? X. If let's say the omega naught is 0. For this case, you must use theta equal to omega naught t plus half alpha t squared. So omega naught is 0, so you put it 0. On the other hand, plus half alpha is 0.1. You can put it negative 0.1 10 squared. Then you can get it 110. So 110, so it's about 5, negative 5 radian. But this is the angular displacement. My question is, what is the linear displacement here? Then you can further use s equal to r theta, which is, let's say the r here is 0.16, then it's just 0.165, and you get the answer, about 0.8. And if there's a negative, you can put it negative, but no matter how, the most important is the magnitude. Okay? When we ask this kind of question, you must analyze. For this question, the most important is magnitude, because we just want to know what is the value. Okay? With that, I finish the kinematic part, and maybe I can move it to the some other part. Let's say Newton's law. Before this, we studied that Newton's law is sigma F equal to ma. For the rotational part, there's an analogy part also, which is sigma tau equal to I alpha. Later I will cover what is I, but at this moment, let us just do this one first.